Okay, welcome back. This is Mr. Hassan's Maths channel, and this is now question number 4 from the October-November 2021 IGCSE Cambridge paper 4, variant 2 from the 0580 course or syllabus. And this question here is about transformations. So here we're given these two triangles A and B. A is shaded and B is not. It says on the grid, draw the image of triangle A after a translation by vector -4, 5. So basically what that means is every point on this triangle has to move 4 spaces to the left and 5 spaces up, -4, 5. So if we choose one point, for example, let's choose the edge here, the pointed part here, this section here. And if we move this 4 spaces to the left, is -4, you're going to go from -2 to -6. And 5 spaces up, you're going to go from 2 up to 7. 2 up to 7, which will be up here. So that pointed part will be on this section here. And so we can see that the rest of it we can draw from that. You know, you're going to have this section which goes up 1 square diagonally across up to there, and this section 1 square diagonally down, and then join those two together. We've got the translation where you just, it has exactly the same shape and size and orientation. It's not rotated, it's not reflected, it's just moved exactly, you know, that distance mentioned or by that vector mentioned. Okay, and there we have the triangle, and that's part 1. So I'll label that part 1 so that it's very clear. That is the answer to part 1. So that's part 1 done. -4, so it goes to -6, and +5, so from 2 to 7. And then every point has been moved by that same amount. Then it says a reflection in the line x equals 1. So first we've got to draw the line x equals 1. Now the line x equals 1 is a vertical line that passes through 1 on the x-axis. So the line x equals 1 will be this line over here. That's the line x equals 1. Let's try and make it accurate. Okay, it goes exactly through 1. On the x-axis, this is the line x equals 1. And it has to be reflected in this, so that means every point has to be the same distance from the line, from the mirror line, but on the opposite side of it, perpendicular. The line joining the point and its image will be going through the mirror line in perpendicular. So it's going to be, basically this point is going to be 2 squares on the other side, and this point will also be 2 squares on the other side, and this point will be 3 squares on the other side. So here we have the line, or the image of this shape, this triangle, reflected in the line x equals 1. So that is the answer to part 2. I'll just label it part 2 so it's clear. That's the answer to part 2. Then it says an enlargement scale factor 2 and center -5, -2. So you're going to have a scale factor of 2 and the center -5 and -2. Okay, so we're going to enlarge triangle A again with this scale factor and this center. The center -5 and -2 is down here. That's the center of enlargement. Okay, so that's the center of the enlargement, and the scale factor is 2. So if you want to enlarge something by a scale factor, one of the nicest ways or easiest ways of doing it, I think, is to use vectors. So for example, if I take this point over here, I can take one point and then we can see what we can do with the rest of it. But if I take this point over here and call this point, you know, the center of enlargement, let's call it point X. Okay, so let's call this point P. From X to P, the vector that takes us from this point to that point is going to be horizontally from -5 to -1, which is going to be 4 to the right, and from -2 to 1, which is 3 up. Now, from X to the image of P, if I want to find the vector that takes us from here to the image of P after this enlargement, I have to multiply the vector by the scale factor of enlargement, which is going to give me 8 and 6. So from the center of enlargement to the image of P, I've got to go 8 units to the right. So -5 to 3, and then 6 units up. So from -2 to 4. So that's going to be the image of P, okay, after this enlargement. Now from there I can work out the rest of it, because I know from P to this point here, let me call it Q. Let me call from P to Q, okay, is 2 units. So from P dash to Q dash, so this is basically P dash. From P dash to Q dash is going to be 2 times 2, which is 4 units. Okay, that's going to be 4 units. Okay, because this is 2, the scale factor is 2, so that means from here, from 4 to 8, that's where Q dash is going to be. And for R, we can see that if I want to go from the midpoint here between P and Q to R, it's 1 unit. So from here, it's going to be 2 units, because everything's multiplied by 2. This is going to be R dash. So once you've got one of the points, you can just scale everything up by the scale factor. In this case, the scale factor is 2. And then you can have your image drawn. So here we have our triangle after the enlargement. Okay, just make sure everything's straight and proper. Okay, so there we have the image, which is part 3, I guess. Okay, so that's part 3 of the question. That's right. So that's A part 3. So there we have the enlargement. So here we have the translation, here we have the reflection, and here we have the enlargement of scale factor 2. Okay, so everything is scale factored by 2, and this is the center of enlargement. So there's the answer to part 3. Now part B says describe fully the single transformation that maps A onto B. Okay, so let me just get rid of these for now. A onto B. So I can see that for sure it's a rotation. Okay, because if I take this triangle here, and I've got something prepared for earlier. If I take this triangle here and I rotate it, I can see I'm going to have that same shape of B. So it's going to be rotation of 90 degrees, okay, for sure. It's rotated 90 degrees because it looks the same as that. So that's one thing I know, it's a rotation. So for rotation, you have to mention a few things. One of them is the fact that it's a rotation. The second thing you've got to mention is the angle of rotation. So the angle is 90 degrees, okay, and we can say that it's going to be clockwise, or let's have a look, A to B, anti-clockwise, in fact. Okay, if I rotate it clockwise, it looks the opposite. So if I rotate it anti-clockwise, it looks the same. So we can say it's going to be 90 degrees anti-clockwise, or if you want, you can say 270 degrees clockwise, but that's normally, you just go the shorter route, so that's 90 degrees anti-clockwise. So we got the fact that it's anti-clockwise, all right, and the other thing we need to show is the center of rotation. Now this is one of the more tricky parts of this type of question, okay, finding the center of rotation. Now once you got used to it, it should be quite easy for you, but one of the ways of doing this is to use tracing paper. Now I know the center of rotation is somewhere going to be between these two. It's going to rotate like this. Now somewhere between these two. Now just imagine you mistakenly thought that this was the center of rotation. Just imagine you thought that. Okay, so what you could do is to test it. Okay, you could take some tracing paper. Now what I have to do in this example here, I have to make sure the tracing paper is exactly halfway. 1, 2, 3, 1, 2, 3, yeah. So something like that. And then I'm going to place this on there. Exactly in the right place. So it's like I'm tracing over this triangle on top of the tracing paper. And then I have to make sure they move together. So I'm going to do this for my... Okay. Then what I can do is I can rotate this 90 degrees clockwise. Now what you'll notice is it doesn't go exactly, it doesn't fit exactly over B. So obviously there's something wrong with this, okay? This is not a rotation of 90 degrees that will take us there. It is a rotation of 90 degrees. It is clockwise. It takes us to the same shape, but in the wrong position. So what we've done here is we've actually got the center of rotation all wrong. That's not the center of rotation. Okay, so that won't be the center of rotation. So what we have to do is you have to try again and think again. Okay, so I'm going to ungroup this and take this out, and I'm going to decide where the center of rotation is. Now, after a little bit of practice, you'll realize the center of rotation has to be somewhere lower, because we ended up here somewhere. So it has to be lower than this. So if I go down a bit, okay, I know it's going to be like halfway between these two, but if I go down a bit, let me try this point here. Now, if you try this point here and we did the same thing, you'll notice that what will happen is this point will end up going over there. This point will end up going over there, because if you think about it, if you rotate that 90 degrees to the left, you'll end up with this. So that point doesn't take us to the right place. Okay, so that won't be the center of rotation. So if you just try something else, for example, go down one more, you'll notice that this is going to be 2 squares up and 1 across. And if you rotate that 90 degrees, that will be 2 squares across and 1 square up. It will take this to the right place. So it seems like that's the right place for the center of rotation. So what we could do is we could put the tracing paper over here. Okay. And what we could do is the following. Make sure it's exactly right. Okay, I can put this over the original object. I could group them together so they move together, and then I'm testing this as a center of rotation. So let's see if that actually works. You can see, yes, it works. I mean, it's not that accurate because my tracing paper is not that accurate, but yes, if you did it properly, it will definitely take you to the right place. Okay, it will definitely take you to the right place. So that's going to be the center of rotation, which is -3, 0. Okay, so the center of rotation is -3, 0. So you write center, -3, 0. So that fully describes this transformation: rotation, angle, direction, center. Okay, that's for rotation. So there's the answer to question 4, part B, and that answers this question on transformations. Other questions from this paper can be found in the playlist that should appear in this link that should appear at the end of the video. Other questions from this topic of transformations can be found in the link that appears over here, and you can subscribe to my channel by clicking on the link that appears in the center of the page. Thank you for watching, and see you soon.